Okay, welcome to part 8 of a video series of short videos on how to use Tellurium, our Python package for building biochemical models. So in this video, I'm going to talk about events. So events are things that you can check there. You can test for various conditions during a simulation, and if those conditions are reached, you can ask the simulation to do something. So it's probably best to illustrate it with an example and you'll see what I mean. So this is the previous model we had in video 7. So I had a linear chain, A goes to B, B goes to C, C goes to D, and A and D are fixed. So let me run this to show you what it looks like. So A and B are fixed, and you can see that we reach steady state, okay? Now, let's say you wanted to say increase K2 at time 30. So at time 30, you wanted to say increase K2 by say 20%. How can we do that? I mean, one way is just to do multiple simulations, and between each simulation, change K2 and then try to knit the data together and do a plot. But that's a bit tedious, really. So an easier way is to use this idea of events. Now, an event, I can write an event like this. You start an event with the word at. So at something, do something, right? So that's the way the at works. At something, do something. And in this case, at time is greater than 30, we will increase K2 by 20%. Right, that's it. Oops, that should be equals. So let's go through this line. So at time is a variable you get for free, and it equals the time of the simulation. So at time is greater than 30. Then there's a colon, do this. And this is set K2 to 1.2 times K2. That's basically increasing K2 by 20%. Now, the thing about this event, so by the way, one thing I haven't mentioned perhaps is you can put in comments like this, all right, an event. Right, so you can put lots of comments into your models. The comment starts with a hash. You can also start a comment with something like that as well. I'll just use a hash. What this means is it looks for basically what the event does. It looks for the transition when time exceeds 30. And when that transition happens, it executes this line here. All right. Now, that transition is never going to happen again after 30 because that's pretty unique. That's a unique transition. It only happens at 30. You won't get 30 again as time moves on. So this effectively means this transition only happens once. Okay. And this will become important when we talk about events that depend on concentrations. But let's come back to that later. So why don't we run this and see what happens? Okay, let's run it. Okay, now you see something. All right. Now, so at 30, you can see that C goes up a little bit and B comes down. And of course, that sounds reasonable. If I increase K2, that means the consumption of B will go up, and that means B will go down. And that's why the blue line goes down. On the other hand, I'm making more C, and hence the C goes up. Notice they reach a new steady state. Okay. Now I can keep adding more events here. So let's say at time is greater than 40. Why don't we bring K2 back to what it was? And it was originally 0.45. Okay. So I can have as many events as I want. I can keep, adding them. Let's run this one. Okay, now you see effectively what's happening is the system is returning back to what it was. All right, so I've restored K2 back to what it was, and we can see that the system is recovering. Maybe I need to simulate it for a little bit longer to see that. Let's simulate it for a little bit longer. Okay, maybe it's clearer now, I don't know, but you can see that the blue line and the orange line, they basically restore themselves back to what it was. Okay, now I can make these changes bigger or smaller. Let's do that. Okay, so you can see bigger changes. Or if I want, I can even I can halve K2. If I do that, sooner the opposite happens. So you can do all sorts of, you can have a lot of fun with events. Now, I mentioned before that these events look for the transition, and when they see the transition, they will execute the thing on this side, okay? In this case, time greater than 30, that transition only happens once because there's no other 30 in the future. There's only one 30. But we could imagine a situation where, let's see, let me run this. So that's what we have without the events. Let's put in an event. If let's say if B is greater than, let's say 2.1, then let me set B to 2.5. Let's see what happens. Okay, so that what happens. That's not very interesting. Let's try something else. Let me see if I can get, if B is greater than, see, 2.4. No. Let's try something smaller. So if B is greater than 1.5, so if it hits 1.5, it's going to increase B to 2.5. Oh, I know what I can do. Let's decrease B back to 1. Okay. All right, there you go. That's what I wanted. Now, what's happening here is that you can see, let me simulate it for less time because it may be clearer as to what's happening. Let's go to 40 instead. Let's go to 20. Okay, that's a bit better. So what's happening here at the beginning, B is increasing, okay, as it tries to reach steady state. The minute it hits 1.5, which is this one here, I basically pull B1 back to 1. Now it looks like it's not quite at 1. I'll explain that in a minute. But now it goes back up again, of course, hits 1.5 again, then it gets pushed back down again. Notice that this transition happens multiple times, which is why we see it happening, which is why we see the event being fired all the time. Now you notice that it doesn't seem to be quite hitting 1.5 or it's quite hitting 1. That's probably because I don't have enough data points. So let's increase the number of data points to 1,000. Okay, now you see it. So now it's much clearer. So now it hits 1.5 exactly, and it gets pushed down to 1.0 exactly. All right. Now you can also see this little effect on C as well, a bit of a ripple there in C as well, as a result of this. But there's an example of an event that happens repeatedly because the transition becomes true multiple times. Okay. So you can do a lot of tricks with events. There's a lot more to events than this, actually. But that's a basic introduction to events. Okay, thanks out.